So my name is Noel Murphy. So there's a few people that have sort of mentioned they're not into the hardware in the talks. I could not be any more hardware centric. My career is entirely in silicon design. So working on chip design for a number of different companies, but primarily Intel in the last couple of years. So what I'm going to talk to you is not particularly Intel centric, but a little bit where the hardware is going, where that technology, real technology trends under the hood are going. And I think you'll make yourself a very large fortune if you can figure out how to intersect where technology is actually going and where sort of the business need is. And so if you can pick up those two things, so I think two people have decloaked as Intel, former Intel people already here this evening, so we have them. This is, very quickly, Leixlip. So this is our facility out in Leixlip. Nothing important to say here other than this, but it is now the most advanced manufacturing site in Europe. Right? I mean, incredible technology going on out there. So, yeah, I mean, this is my world, right? So it's very hard to sort of even explain to ourselves, you know, how incredibly dense electronics is at this point. But how many people remember, say, you had a Pentium computer? Pentiums, how many Pentiums? DXs? Those would run 25 megahertz. They would have sat in a box about yay big. They now run probably about 20 times faster, and they sit, if you look at your nail, small finger, your nail. So we can now make them for about 1/10 the size of the nail on the back of your finger. Right? That entire box is now collapsed, running 20 times faster. So this technology and the ability to put like really powerful, complex processing is unrelenting, right? This is about where we are now. So your modern phones are coming right around here. 22, irrespective of Intel or coming from the other, our sort of competitor foundries. That's going to half again next year, and it's going to half the year after. Right? So the technology, your ability to put really advanced computing, you know, into tiny areas is just unrelenting, right? Absolutely unrelenting. And what would you do with that, right? So we talked about, you know, the sensing light, heat, temperature, but where a lot of folks are headed with that technology is doing sort of ECG algorithms, you know, sort of any sort of looking for, you know, I think we talked ECG earlier, but, you know, specifically technology that can sit there and just look for an anomaly, right? Just sits there, does nothing, may do nothing for its entire life, but it's just looking for an anomaly, right? We already have that technology, you know, in pacemakers and different ways, but, you know, the ability to do very advanced analytics is here right now. Right? It's just how we choose to deploy it. So, you know, in 1970, it cost $1 to make a transistor. Right? Now, you know, $1 makes 1 million transistors. There are more transistors made every year right now than there are grains of rice. It's just a phenomenal business in terms of just generating, you know, that compute complexity. Where do we come in? I think we've had a number of mentions for Galileo. So let me just talk a little bit. So I set up, we have 2 design centers in Ireland, one in Shannon. I set that one up in 2000. About 4 years ago, I came to set up what's become Quark, Galileo, you guys were mentioning. So I came up to Dublin to set up our design team very end of 2010. That design team is now doing a product line called Quark. I think we mentioned Galileo, but I'm responsible for that and also the wearable SoC, so the wearable technology for Intel. So we saw plenty of wrist-worn, watch-worn, eye-worn. So that technology is technology we're developing right now. Edison is just a form factor. So this chip is about, again, big as your thumbnail. Blows up really big in these things, right? About as big as your thumbnail. Edison's an SD form factor, SD card. Remember those SD cards you would plug in? So essentially an entire computer on an SD plug-in card. Again, We don't know how these technologies will make their way out into the world. You can see the Galileo that's over there. Some of these technologies are quite large. If you go into an industrial setting with something like, you're tracking, I think we said temperature, we're talking about tracking temperatures in fridges just before now. So there's huge industries in transportation around tracking, temperature, heat, humidity of goods. So if you're tracking, we said medical goods just before the break, but in fact everything's being tracked now. Milk, yogurt, temperature of everything in the supply chain from when it leaves a creamery all the way through to the distribution, to the truck, all the way to the end. So end-to-end tracking, is becoming sort of really important. So Galileo, we launched, so I think I started this journey with Intel in 2011. In 2013, we launched Galileo. So we went out to Rome. We were enormously impressed with a guy called Massimo Banzi. How many people? Massimo? So Massimo and a bunch of academics in Turin went off and did Arduino. Right? So Arduino is the default open source platform really out there for makers. And we were tremendous fans internally of Arduino, right? A lot of Arduinos, in my area with my team. And one of the things we thought we could bring to it was essentially Arduino now runs as a bootloader. It's a pretty simple device. Runs 25 megahertz, does really great things. But what we thought we would bring to it is a complete Linux computer. So the team here in Dublin worked to put an entire Linux computer underneath that Arduino, so to give about 20x the processing power, but it opens you up to the entire world of Linux, right, which is a huge compute platform in itself. And we retained, the shields. So if you worked with Arduino, it's about 500 different sort of plug-in shields you can use in an Arduino to measure temperature, to measure motor control, drive motors, photovoltaic, anything. Really, go onto Google and you can find an Arduino shield for everything. So what we worked with here in Dublin was to really take that, all that goodness, preserve it, and put a Linux computer on it. So you could not just taking sensor data, but you can run some very advanced analysis right on that data, right? So a lot of reasons you would want to do something like that. For those of you, especially out of Trinity here, we probably pushed certainly over 1,000 of these units into the college system here, right, into the universities. So we've shipped an awful lot into at least this many universities and more. So what we was trying to do is, certainly in the last couple of years where colleges had zero money, in terms of building a new sort of hardware labs, we've shipped 1,000 boards to 21 different institutions across the country when this was made, and probably a lot more at this stage. So it's really try and get A, Arduino out there, B, Linux out there into all the college labs so we can sort of upscale and, bring Internet of Things and these sort of applications into the sort of college labs. So it's a big donation program still underway into all Irish universities. So I said I work in Internet of Things wearables. What's the difference? What's the difference between wearables and Internet of Things? Embedded computing. To me, they're all the same, right? They're just a continuum, right? So for people who are taking their computer, their laptop, and attaching a dongle to it to do something way back, 15 years ago, to Internet of Things, which is sort of really Arduino world right now, to wearables, it's just the same thing. From a silicon designer like myself, they're just different targets of power, different targets of form factor. The underlying technology that's actually in them is incredibly similar. The underlying software that's in them typically very similar, and the issues you have to face. So really, to me, this is how we look at Internet of Things. But wearables is just an extension of that. I love the hype. It's fantastic. You get to, because it begins with W, you can have it with Wednesdays. Okay. But it's just an extension of embedded computing all the way. we have a lot of work going on. Transportation, we mentioned. In transportation, in terms of just remote monitoring of either goods in transit, or what's the name of the car? What's the car rental crew here? Hire a car for an hour.
Go-kart.
Go-kart. Okay. So companies like Go-kart, I mean, really interesting. So somebody asked about earlier about sort of e-waste and stuff like that, right? I mean, look at a company like Go-kart, which is eliminating, automobiles out of the city fantastically, right? So we're working with a lot of companies like that to put, smart intelligence in the car, so that you walk. So if you hire a car, right? So if you've ever hired from Hertz or Avis or one of these companies, and they make you go off and march to this big shiny building outside the airport where you collect all the hire cars. You drive it around for a while, and you do your thing, and they march you back to this other building. Something like future cities would be much more like, Dave, what's your car doing now?
I've been in Google Car, so
where's your car now?
It's in the garage.
It's in the garage, doing nothing?
And I've got another car, so
oh, worse again. Okay, so someone could clearly have been using that car for the last couple of hours. Quite simply in this
I think they become public transport.
Yeah.
And they become cop cars as well. Because they have to have cameras on, so they have to be snitches. So
these are snitches. So imagine a world where your car, is just to rent. There's already services in San Francisco where, if you're not using your car for most of the day, which for a lot of us, your car just stays there for the day, you can, such that your car is brought back and parked roughly in the same area. You can set how much disturbance you want to do to your life. Rent a car. People like Go-Car, where you can rent a car for an hour, right? Where you don't need a car outside the door. Right? That whole sort of enabling of Internet of Things, we're doing a huge amount of work with different companies in transportation. The other good thing they do is they put in accelerometers. So if you crash Dave's car when you're driving out for the last couple of hours, you get a nice text message to say,
there's the other things they do inside of the stuff.
You leave a camera in.
Do they measure speed as well?
Speed, absolutely. Everything on a CAN bus, right? We can show you real demos of taking. It's on the CAN bus, so it can see how you turned, see what speed you do, see torque in the engine. I mean, there's nothing that's not reported on.
Can they do a remote shuttle?
Yeah, it might be a little dangerous. They can certainly limit your speed. Are really nice applications where you walk down a street to a car and, just with a text message, the doors pop open, right? Keys are inside, walk in. When you're finished hiring your car, no need to go to that big Hertz building at the airport, just park it on the side of the street, close the door, done. Right? So, it's going to be a pretty fascinating world. One other thing we're doing here an awful lot, especially if you go to the bottom of Grafton Street, look up on the poles, you'll see a lot of what's called City Watch, city sensing. You can go to City Watch, where you can start to look at the air quality, traffic quality, pollen count in the city right now. Right, so you can go on live, look at these sort of Quark boxes that we've deployed all over the city. We've deployed here, deploying in London, just to, for citizens, so as citizens of the city, to make it a smarter, more habitable, better place for you to live in, right? So if you're asthmatic, before you go out the door, you know what parts of the city are high power cut, low power cut. So huge amount of this IoT deployment going on. We're part of it, especially here in Dublin. We're a big part of it in London, but you're seeing it going on across sort of lots of different cities. It's interesting for a guy like me to think about what are the challenges in wearables, right? Because how does hardware centric as you're going to go? Can they be worn, washed? I mean, yes, right? I mean, a silicon device at the end of the day is like a piece of glass. Really? That's really what it is, right? That's IoT. So it can absolutely be washed. This is called the M-Dress. There's a very futuristic company on the wearable side called Qt Circuit. Done a lot of work. You can look them up online. But this is an M-Dress, so it's got a SIM card underneath the hook. So you just got a SIM card, pop in your SIM card. addresses in a phone. Right? You can buy that online. Can it be powered? Yeah, it can be powered, but the one technology that's absolutely a killer for all of us in the wearables markets is batteries. I mean, it is the most horrible, slow-moving, really, I mean, it's been crying out for an advancement for a number of years, no shortage of money poured into it, and nothing, as far as I can see, coming out in terms of, a really sort of quantum leap. Silicon's getting 2x better every 2 years. Batteries are just crawling now. We're still walking around with those lithium batteries, just horrible. We'll talk about power in a second. How do you communicate to it? What radio standards are you going to use on wearables? I mean, our view is certainly Bluetooth LE. Alright, so for anyone with a phone right now, it's heading for Bluetooth LE in our opinion. We've got Zigbee, which is more industrial sort of applications. For personal areas, seems to be heading in that direction. Here's a really interesting area. One I'm very interested in, skin. Right. So it turns out skin is actually not the worst. You can communicate over skin. So if you put a phone that's touching skin here, you put something that's touching skin, your foot, anywhere on your body. Turns out skin is a pretty good communicator. You can actually have a whole network just running on your skin. It's not high data rate, but for jogging or temperature or anything else, I mean, it's very interesting. An awful lot of work going on in Philips, going on in research in the continent about that. In our bodies, would we put electronics in our bodies? Absolutely. I think it's, the technology's there. It's just a societal nervousness about it. The technology is way beyond ready to be inserted in. So I think we will, and we've already seen it in pacemakers. We'll see it in, I think, sort of medical areas where we need to, mediate a condition. Where you an intelligent, timely intercept from a piece of electronics can prevent a condition from, going better or worse. It's much more Dave's area. I can tell you from the technology side, absolutely ready. Right? We can absolutely do the silicon. From a powering perspective, the technology to do power over the air, to supply power to somebody over the air is already there. You're seeing these charging mats come out now where you just put a collection of phones on top of a mat and they'll be charged directly over the air. The same technology applies to bodies. So being able to put technology inside the body and power it is there, already there. Will we elect to do it? Absolutely. We absolutely will in time. Here's a few just quick one, Nixie, so I'll just go through some of the quick ones. This is a really nice one I like. It's currently the leading contender in the Intel Wearable final. So this is a quadcopter you wear on your arm, wraps around your wrist. When you are out sort of climbing walls or cliffs, like most of you people do at weekends, and you want to take a photograph of yourself. You unleash it, throw it like a boomerang. It moves away about 20 feet from you, turns around, takes a photograph, and comes back down to your wrist. Very cute, right? Really nice, wraps right around your wrist. So if ever you're in that sort of, so when you want a nice area to photograph on a picnic, or you're in a park, or you want something, just quadcopter, photograph, back to your wrist. Okay, power source, nearly there. There are some very simple applications now that harvest power without batteries. Right, so that revolution is just about there. And if you remember, you saw that march of sort of silicon down. That's not just in terms of area, that's in terms of power. You can get incredibly complex circuits at very low power. You can harvest power, right? Kinetic. I mean, you can already get a car tire that measures its own pressure, right? And it's just powered from the rotation of the wheel. Easily there. Radiation. This building is flooded with Wi-Fi network. You can sniff on that Wi-Fi network. You can actually extract, right here, you can extract enough power from that Wi-Fi network to power a wearable. That technology is already there. Pressure. Any of you have gone to the Young Scientist? I hope you do go to the Young Scientist. You see a ton of projects down there with sort of shoes that are fitted by transition year students with piezoelectric crystals that can, based on pressure, will generate power. So there's an awful lot of work going on here in terms of harvesting power. Currently, they're limited to very infrequent updates, right? So you really can power a phone at this point. You can't really power, in my opinion, sort of any sort of complex electronics. What you find are things which do sort of sporadic updates of data. Like the temperature is, and this thing expends all its power sending out a little pulse of data, dies. Dead flat. Sits there for about 5 minutes trying to harvest up enough energy. Once it gets to enough energy, spits out the temperature now is, dies. 5 minutes. So that's the level it's at right now. But that's not the level it's going to stay at. Here's my other second favorite in the current Intel Wearables competition. So this is a fully integrated vision. So it's a first vision for players. So not just those really horrible, clunky ones that rugby referees are wearing this season, if you've seen them. Big sort of camera sitting on their chest that goes around like that. This is fully integrated into that. So every player on the pitch, you would have their view of the game. So you could be, you could dial back last night to John O'Shea's t-shirt, right? In the 93rd minute or whatever, and you could sort of have the whole, experience of John O'Shea sticking out his right foot.
You see it 2 o'clock in the morning.
John O'Shea saw it 2 o'clock in the morning. Okay, last slide. Just on a very fast tour of hardware, right? My words. We're just starting to. I've seen the first really good startup now that can do a continuous, always-on, low-power radio with no battery. Very first one of those. Just about there. Self-powered wearable devices, they're just not there yet. Will we see them in our lifetime? Will we see them in 6 years? Absolutely. Absolutely coming, that technology. There's so much work going on into batteryless, into continually powered. We will be able to see wearable devices that we can wear and wash. Absolutely, technology is already impervious. Silicon doesn't particularly care about washing too. But this is the Holy Grail, and this is what you're going to see in your lifetime. I'm seeing sort of snips of it. Okay, that's all I have between you and the pub.